Okay. Okay. So let's go through the I will share my screen. Let's go through the items stay. So uh the first item is from Matt about the diffusion Iceberg integration. Yeah. Hi Matt, do you want to share about this?
Yeah, is it all right if I share my screen real fast? I just have like a kind of a few slides to kind of give an overview.
Okay, you can. Okay, let me stop sharing. You can share now.
Second. You guys can see the slides, right? The title
Yeah.
slide. No notes. Okay.
Yeah.
So I just want to talk for a few minutes about a project that I'm working on. This is the first time I've attended one of these Iceberg Rust community meetings. So I'm Matt. I work at Apple. I mostly work on. I'm a Apache committer for Data Fusion and the Data Fusion Comet subproject, and I work on ArrowRS quite a bit. So I want to just talk a little bit about a project I started working on only like a week ago. Um, so for some context, very briefly, what is Comet? Comet is a Spark accelerator built on Apache Data Fusion. If you don't know Data Fusion is an open source query engine written in Rust that is Arrow native. Iceberg Rust actually uses like a lot of the same ArrowRS code. For Spark, it accelerates things like shuffle, data loading, a lot of the operators, expressions, and functions. And we fall back to Spark for unsupported operations, and we support Spark 3.4, 3.5, and experimental support for 4.0. Should be actual real support pretty soon. We should be donating jars or building jars for Spark 4 soon. And it was donated to ASF by Apple almost 2 years ago now. So Comet works with Iceberg a little bit right now. I want to give like a brief intro to how that works now and what I want to do differently. So currently in Iceberg Java, the standard Iceberg implementation of Java, it checks for whether you've set the Parquet reader to be equal to Comet, and then it knows how to instantiate these Comet batch readers that use a lot of the Spark JVM and Iceberg JVM code to still do all the I/O credential management. So if you're talking to clusters that require custom signers, authentication tokens, all that stuff. It's all still handled in the old code paths. Same with decryption, decompression. And then the only thing that's native code is Parquet column decoding. And so that doesn't support things like complex types yet, and it doesn't support newer types that are being added to the spec like variant and geo. There's a work in progress improvement that uses data fusion for a lot of this work. So you get a lot more of the work done on the native side. We get support for complex types. But we're still doing some of the Iceberg specific logic, I think, like to try to do delete rows and stuff like that on the JVM side. But it could support native the newer types as well. So what does that kind of look like right now? Like basically in blue, you have Iceberg. The code flows from top to bottom. Basically, Iceberg, when we're going to do a scan, it starts to instantiate these Comet columnar batch readers. These batch readers read the Parquet pages. The native code on the right side then decodes those Parquet pages to Arrow. They get passed back to Iceberg. They get turned into columnar batches. Spark then proceeds to turn those columnar batches pass it to any further operators if necessary. If it's just a scan, then it would just go straight to the output. But assuming you want to do join or anything interesting, it's going to go back to Comet and do the native side. In contrast, this is like sort of the work in progress one. It looks pretty similar. Still has a lot of back and forth between JVM and native code, but like the only real difference here is in the top two Comet blocks where the native batch reader really only reads the metadata and then it passes the rest over to Data Fusion to do all the Parquet reading, decompression, decryption, and create arrow batches. But then it still gets passed back to Iceberg. You'll notice like all this sort of wrapped in these blue boxes of like Iceberg Java is sitting there and actually coordinating this, and this requires code to exist already in Iceberg Java to support Comet. What am I proposing instead? So Russell gave a cool talk a couple weeks ago. I've linked it here. Sorry, was there a question?
I think I can see your slides. Is this I'm not sure if this is my problem or everyone else.
Does anyone else see slides?
I can see the slides.
Okay.
That's okay. Let me refresh the page. Oh, I can see now. Sorry.
Awesome.
So, go on. Yeah. Sorry.
Yeah, sorry about
Mm.
that. Feel free to interrupt if you need anything clarified or if any technical hiccups happen like that. So Russell gave a cool talk a couple weeks ago where he sort of gave an overview of how all of Iceberg's planning works, and I can link these slides to folks in the chat or something like that, but because that's a link that works. But um, it kind of inspired me to actually look at the file scan task abstraction and think like, okay, that's actually, it seems like an interesting way to hook into what the way Iceberg integrates with Spark right now. So basically, after Spark and Iceberg do all the planning, do all the pruning, they just generate all these file scan tasks of what they actually need to read. What I did is I take those from Comet. I changed Comet to take those file scan tasks from the JVM code and serialize them over to Iceberg Rust, which uses basically the same abstraction, right? Like these file scan tasks, to create an Iceberg Rust file AO and arrow reader object, and then read all of those based on the task list. Um, and basically, we have this new operator called an Iceberg scan exec, which produces arrow batches and feeds them into other Comet nodes without crossing the JVM boundary. So what does that actually look like contrasted? Like, it's quite similar. Like, you still have Iceberg at the top on the JVM side that does all the planning and eventually output these file scan tasks. Comet takes those, serializes them to native code. We read them directly to Arrow. They go into any further downstream operators, and then the results go back to Spark. So this is, in my mind, a much cleaner design um, than the way Comet works currently, basically for Iceberg integration. And I can sort of articulate some of those benefits. One, we no longer need code dependencies in Iceberg Java related to Comet, which is causing a lot of problems for us. We have circular dependency issues. We have Java jar shading issues when we go to compile, particularly when you want to put Comet, Iceberg, and Spark into one distribution, which is kind of the way we want it to be used. You get better performance for scans. You're not going back and forth across the JVM as much. It's not obvious, but like we have to use a separate data fusion, basically execution context just for Iceberg scans because it's being initiated from actually within Iceberg, which isn't great for us. And this is actually a pretty cool benefit that I think is actually going to really help Iceberg Rust is you can effectively run all of the Spark and Iceberg Java tests now on Iceberg Rust through this API. Now, granted, maybe not everything's going to be supported, but one example is like I've already found an issue with not in pruning in the Iceberg Rust code base based on like behavior I saw when running a bunch of different test suites. So I could submit a pull request up to Iceberg Rust for that. Like having that coverage has done a lot for data fusion and like the underlying Arrow Parquet reader when we find bugs that way. So you have this massive corpus of tens of thousands of tests that we could easily run against Iceberg Rust now through this interface. And I've already tested this with Iceberg 1.5, 1.7, and 1.10 with primitive tests, like not like these full test suites that I'm talking about. And my goal would be to actually be able to contribute more to Iceberg Rust and Arrow RS instead of sort of this bespoke Comet logic that's kind of difficult to maintain right now. It's difficult from an engineering standpoint, and we would like to put more, engineering resources behind Iceberg Rust. So there are a few concerns that I kind of wanted to bring to the group, and hopefully maybe you guys can tell me if I've made some very poor assumptions about how this system could work. I do need some minor existing API changes. One is to make the Arrow Reader Builder new public, not just public crate, because we're effectively bypassing the table API. I don't want Iceberg Rust doing any planning. It's been done already. The API we're working at is file scan tasks already just being passed into Iceberg Rust. Another is I need a lot more API changes about talking directly to the Arrow reader. So for example, I mentioned we've done a lot of changes for Arrow RS. We need support for things like we've already pushed it into Arrow RS. I just need to be able to change the options for the Arrow reader for things like Spark compatible int96 support. There's a flag I need to turn on there so that it knows how to read int96s correctly in a way that are Spark compatible. We recently merged Parquet modular encryption support. So I need a way to pass in our encryption credentials into the Arrow reader so that it can do the Parquet modular encryption work for us. I need to, this is more of a Comet thing, but like we have a bunch of code that handles credential providers. I know Iceberg Rust relies on OpenDAL, I think. we have some code from FSHDFS, and then there's also the Data Fusion like object store, ArrowRS object store stuff that I need to understand like what the common language is between them.
What is the what? Sorry, what is the common?
Like sort of what is the common abstraction? Like what is the common behavior between OpenDAL, FSHDFS, and object store with respect to and maybe this is really just a Comet issue. Maybe it's just figuring out how when Comet gets credentials from Spark, how to pass them into all these different ways to represent accessing an object store, if that makes sense.
In community, we have several several requests from community to ask us to support using object store as the backend of FireIO, and currently there's an issue to track this. Let me share the issue.
That would be good. I think Data Fusion and ArrowRS mostly rely on object store. My initial benchmarking showed really poor performance out of OpenDAL's file I/O when I was testing with Iceberg Rust. But that may just be a my machine issue. I'm not totally sure. So there's also this mismatch between we need to do some schema change stuff when batches come out of Parquet sometimes in terms of how we want types cast and like fixing missing columns, default values, things like that. Data Fusion has something called a schema adapter, which they're actually moving towards something called a physical expression adapter to be a little bit more generic. And then I know Iceberg Rust has a record batch transformer. I don't know what that does at all right now. I just think I need to compare the behavior differences between the two, but there appears to be an interface at least to do these sorts of things.
I think they do similar things, but recorder back transformer is used to handle, the schema evolution, missing column things, like similar things, like in Iceberg. Iceberg schema evolution is lazy, right? So
right.
When you read from Parquet file, you may miss columns, and you may need to do tab promotion. This was record transformer do. Yeah.
Perfect. That sounds like kind of a lot like what we need. It's unclear right now how much. I'm not actually sure how ArrowRS. Excuse me, that's a mistake. That says ArrowRS. It should be Iceberg Rust. It's unclear to me how it actually uses Data Fusion right now. So like in my fork, I just bumped it to Data Fusion 50, so it was in sync with what we're using in Comet. We might try to make sure, and I already saw a pull request open to bump to Data Fusion 50, but I think you guys are trying to get the 0.7 release out the door, so stuff's a little bit on hold. But we would be doing some of the work for you as well to try to keep Iceberg Rust in sync. We're used to doing that sort of stuff with Comet when Data Fusion bumps, so we're pretty good at it. If there's code that needs to be adapted. Yeah, sorry. Go ahead. Oh, okay. So my kind of these are the sort of questions to the group because this is all kind of prototype code for me right now. Like the Iceberg Rust code is effectively catalog oblivious. It doesn't know anything about the catalog. It doesn't know whether it's a Iceberg REST, glue. It doesn't matter from my perspective. I think all I pass in is the file scan tasks and the metadata location. Is there any obvious issue with something like using something like that that I'm overlooking? And the other, sorry, go ahead.
Currently, one issue is that we currently don't support nested types. We only support primitive types.
So even though the underlying Parquet reader supports complex types, the Iceberg Rust does not support complex types.
I think so, if I remember correctly. Yeah.
Okay. I'll take a look at that because that would be a requirement for us.
We need to handle the type promotion because we currently don't support nested types because if we support that, there are more work to do in the planning phase. The certified uploading and the transformer, the record batch transformer phase, right? Type of promotion, things like that is more complicated for pure primitive types.
Interesting. So it sounds like it's mostly a planning limitation. So if I already have file scan tasks, I would mostly just need to update the arrow reader to make sure that it works with complex types. Is that accurate? If I'm bypassing
so.
all the planning work.
I think so. Yeah, I think so.
Okay.
But you all need to be careful if you want to contribute. You also need to be careful with the record batch transformer part.
Right. Right.
Okay.
Okay.
And about your question of how Iceberg Rust uses data fusion. Currently, there is a crate. There's a crate called Iceberg Data Fusion crate. It provides it provides some data fusions as a table provider and
Right.
catalog provider for data fusion. So that users can use data fusion to access Iceberg tables using
Makes
SQL.
sense.
Yeah. Mm-hmm.
Gotcha. Cool. Thank you. So, and I guess the last thing, which again is like, it sort of ties into what we were talking about before with the complex type stuff. Like, are there any obvious concerns with if I do my planning in Iceberg Java, which assumes, like, let's say, for example, and I don't know enough about the differences to say, like, if they say that they implement table spec v3, right? And does that affect the planning and that the file scan tasks that come out? But like if Iceberg Rust only supports table spec v2 or even a subset of table spec v2, am I going to get incorrect behavior? Or is basically the main difference is, you know, you would get equivalent file scan tasks out at the end. I guess I'm not sure yet. I mean, maybe there's only one way to find out.
I think maybe you will not get incorrect. Let me see. If you say you use Java to plan Iceberg till v3, because currently we don't support there are some missing features like deletion vector support, right? So this if so I think you will mainly see error but not incorrect behavior,
Right.
because say you add you add deletion vector proofing file which contains deletion vector, right? But Iceberg Rust can read it, so it will report an error, but it will not say, okay, I will return an incorrect result. I think.
Okay.
Yeah.
But you do support equality deletes and position deletes, right? Just not the deletion vector. Is that right?
It supports equation deletes and position deletes, but not v3's deletion vector. Yeah.
Okay. Yeah, I'm not too concerned about table spec v3 just yet, I don't think. But again, like these are things that I think we would have engineering resources to start putting into Iceberg Rust, you know, if we move towards the solution for Comet, because the goal would be to get a lot more of this functionality into Iceberg Rust quickly. So yeah, in summary, I'm not going to take this whole meeting. Like Comet currently supports Iceberg with a bunch of dependencies in Iceberg Java. It has circular dependencies, shading issues, and performance limitations. I have a pull request up on Comet right now. It's draft. We're just sort of proof of concepting this. That basically uses the file scan tasks, passes those to Iceberg Rust to add native Iceberg scans. We need more work on the Iceberg Rust APIs at the arrow reader, but we are excited to kind of pursue this approach, and we'd like to see this sort of community continue to grow together, because I think it's been a big benefit for data fusion and arrow RS in particular to have. You know, I can't promise how many people at Apple would be working on this, but like it would shift more engineering resources towards contributing to Iceberg Rust instead of sort of custom Comet code, I guess. In addition to, I think the community, like we would like to see Iceberg as a first-class citizen in Comet and have better support, because I think a lot of people are interested in, you know, using, unsurprisingly, Spark with Iceberg. So that's what I got. Hopefully,
Okay.
any other questions, comments? Like, it's not so much a formal proposal to the community. I think the biggest thing is like, do you see any issue with? We mostly need a lot of arrow reader option. We basically need access to the arrow reader options, but I think I already found a reference in the code base that said like ArrowRS wasn't exposing it in a clean way for you at some point, and once a PR got merged there, uh, we would like to see that available in you can start tweaking some of those stuff. Like basically, like is it incompatible with what Iceberg Rust's vision is of like we want to go straight to your arrow reader. We think that implementation is nice. We want to improve that. We would effectively be ignoring all of the planning work, at least for comment. Like we're not as interested in using any of the front end stuff. But I do think it would greatly improve and harden and make it more robust, the arrow reader, and add functionality, like you said, for things like table spec v3 features, deletion vectors, stuff like that. Does that sound so far uh, like an okay idea, I guess?
Yeah, I think sounds a good idea. Yeah, but uh, previously we had some discussions in community that we want to move the arrow reader out of the core Iceberg crate. It played in a standalone crate, but we haven't because currently some users from the community's point, we want to users say when you want to access when users want to access Aspect table, you are supposed to use high-level APIs like data fusion integration, right? You can use SQL to access table, but some users want to say, oh, but in fact the arrow reader is a low-level API, right? It
Right.
accepts yes, I think I just skimmed through your pull request, and I think you are using it quite in the right way. So the arrow reader is supposed to be used in a distributed query engine in a single task, right? The reader should not care about things like say thread management, resource management, things like that. It only contains logic to pass read pocket files into arrow, right? But
Right.
some users wants to use that directly to read Iceberg table in parallel. That's why we had a discussion to move it out, but it is supposed to be a low-level API. I think
Yeah.
I just skimmed through your products. I think it's in the right direction. Yeah,
Cool.
that's
Thanks for
good to
letting me
see that.
chat for a few minutes. But yeah, I'm excited.
Okay. Okay. The next item is okay. I'll share my screen. So the next item is it's the voting thread. I was on vacation last week, and I think currently we already have enough binding votes, right? Yeah, I think it should pass now. We have 3 binding votes. We can release it tomorrow. Yeah. Okay.
Sorry, I was muted.
So
In general, what is because this was something we were looking at as we're evaluating whether we want to move towards Iceberg Rust. What is the typical release cadence that you target, if any, for Iceberg Rust? Like, do you like what's the general approach to releases, right? Because I don't think there have been a ton of releases in the last 12 months.
uh, do you mean release new version or the a stable 1.0 version release recently?
Yeah, I guess like a major version, right? Like since there was one there was point 0.4 in December, point 0.5 in June, and point 0.6 in July, I guess. Like is there was that mostly driven by like implementing like major milestones in like the table spec or front end? Like, is there any sort of planned release cadence, or is it just whenever like a major feature goes in or something?
No, we don't currently we don't have a clear roadmap to for the 1.0 stable version, but per our previous discussion, we plan to release the minor, say 0.7 or zero point 0.8 every month, so that users can
Okay.
use latest release more frequently. Yeah.
Cool. So the goal is to get to a monthly sort of rolling point release.
Yeah.
Cool.
That's it.
Cool. Thanks.
Okay. I think
Awesome.
that's all for today.
Thank you.
Thank you, guys.
See ya.
Thank you, guys. Bye. See you.